Today we're going to look at 8-4, multiplying and dividing rational expressions. Our goal is to multiply and divide rational expressions. So let's look at some review problems. So attaching this to our prior knowledge, if we look at a problem like this, we would divide by 2, reducing the numbers by what they have in common. So this makes 186 over 28, and then divide by 2, 93 over 14. So they don't have anything in common, so that's reduced. Another way we could look at this is 2 times 93 is what 372 looks like. 2 times 14, and we cancel out what factors they have in common. So we get 93 over 14, which is kind of similar to how we do this with polynomials. So looking at this problem, first thing we're going to do is we're going to factor. So we're going to have x plus 2 times x plus 5, because 2 and 5 multiply to make 10, and they add to make 7. And then underneath, we're going to have x minus 2 times x plus 2. It's a difference of 2 squares. Then we cancel out what they have in common, right? Because anything over itself makes 1. So x plus 5 over x minus 2. And then looking at the domain, we set the denominator equal to 0. X cannot be 2. The same place where it would have a vertical asymptote if we were going to graph it. Alright, let's look at this one. Again, going back to review, where we're multiplying two fractions. One of the first things we can do when we multiply two fractions is simplify diagonally. So what number do 4 and 22 have in common? They both have 2. So 4 divided by 2 is 2. 22 divided by 2 is 11. What do 15 and 27 have in common? They both have 3. So 15 divided by 3 is 5. 27 divided by 3 is 9. Multiply fractions straight across, tops times tops, bottoms times bottoms. You get 18 over 55. Alright, so looking at a similar problem, just the one that has rational expressions instead of numbers, let's look at simplifying this thing first. So it's a binomial, so step 1 is GCF. They both have a 2x. 2x squared divided by 2x is x. 4x divided by 2x is plus 2. The second one, we're going to go ahead and factor, is x squared minus 9x plus 18. So what two numbers multiply to make 18 and add to make 6? Or add to make 9, sorry. X minus 6, x minus 3. Right, then we'll factor this. What two numbers multiply to make 12 and subtract to make 4? 6 and 2. The signs are different. The biggest one gets the 4 sign. 2x is a monomial, so it doesn't reduce. So in class we kind of talked about binomials holding hands. So x plus 2, they're holding hands, right? They're connected with that plus sign, so plus and minuses, they like hold each of their terms together. But things that are connected by the times, like this 2x is connected to x plus 2 by times, which is just a little tiny dot. It doesn't have any arms to hold on to. So 2x and 2x can be canceled out. X plus 2 can be canceled out, can reduce with x plus 2 because we can take them out together. So we can't just take the x, we can't just take the 2, but we can take the x plus 2 all at the same time if we have another x plus 2 on the bottom. Then x minus 6 over x minus 6 makes 1. So the only thing we're left with is x minus 3. This time I don't have any restrictions on the domain because the denominator is just a positive 1. So right now we're good. So let's go ahead and go to the next one. Alright, so you'll try this one first, so you can pause the video and see if you did it right. And then we'll restart the video when you feel like you have the answer. Alright, so let's see if you did it right. We'll have x minus 5 times x plus 3, x plus 3 times x plus 1. Alright, they both have an x plus 3. So x minus 5, x plus 1. Or x cannot be negative 1. Alright, continuing on. Let's look at this one. So again, practicing what we just did, very similar to the question we did before. So pause the video, work it out, and restart the video when you think you're ready to check your answer. Alright, 6x, x plus 3, x minus 2, x plus 1, x plus 3, x minus 2, x minus 8, x plus 1. Right, so first thing we do is we factor everything. Now we're going to reduce. So x minus 2, x minus 2, x plus 3, x plus 3, x plus 1, x plus 1. So I'm left with 6x over x minus 8. And in this case, where x cannot be 8. Okay. Alright, let's look at the next. Alright, this one. Looking at what happens when you take a fraction times a whole number. So we remember that we take the whole number and we put it over 1. We take tops times tops, bottoms times bottoms. So we get 24 over 5. So we're going to apply that same philosophy to this next problem. First thing, we put this whole polynomial over 1. Right? X minus 4 is already factored, it's prime. X squared minus x plus 1 will not factor, because the two numbers that multiply to make 1 are 1 and 1. And those numbers add to make 2, so that won't factor. This is the difference, or the sum of two cubes. So remember the pattern is the cubed root of the first, the cubed root of the second, square the first, multiply the 1 and the x, square the 1. The signs are the same, opposite, always positive. Right? Simplify, so this x squared minus x plus 1 can simplify with this x squared minus x plus 1. So write down what's left, x minus 4 over x plus 1, where x cannot be negative 1. Alright, let's look at the last one. Okay, so again, trying to make sure that you know what you're doing. So if you wanted to stop the video to work it on your own, you certainly are welcome to, and then check and see if you got it right. So on this one, x plus 9 times x minus 4, x minus 4 times x minus 7, x minus 7 times x plus 7. So factor everything that can factor. Alright, these x minus 4s are both on top, so they can't cancel out with each other. They would just multiply it together to make x minus 4 squared. So if you accidentally cancel those out, hopefully now you understand why they don't cancel out. The x minus 7 does cancel out with the x minus 7. So on top we're left with x plus 9, parentheses x minus 4. You could have also written x minus 4 again, or we just write squared, which means x minus 4 times itself. All over x plus 7. And then we'll say x cannot be negative 7. Okay? And your assignment on this page. Right, and that's supposed to be page 577. A lot of 7s in this assignment. Okay, good luck, and if you need any help, please come in and see me. Thank you. Bye.